Hey everyone! So today we're going to be solving subsets, which is a Leetcode problem, and this problem actually focuses on backtracking, and I'll get more into that. So for this problem, essentially we are given an integer array nums that has unique elements, and we have to return all possible subsets, or in other words, the power set. So for example, if we have in example 1, basically we have 1, 2, and 3. And here the possible subsets can be 1 by itself, it can be 2 by itself, or it could be 3 by itself. We can also take in multiple elements as well. So we can have 1, 2, 1, 3, and also 2, 3. And then of course, the subset can be the entire array, or it can also be an empty subset. Just like that. And for this question, it's important to note that we can't have any duplicate subsets. So for example, we can't have something like 1, 1. We have to use all the elements by itself, just once. And yeah, so basically this question focuses on an algorithm called backtracking, which is essentially a brute force recursive way to get through all the possible solutions of this question. So essentially the way that it works is that we have to make a decision tree in the sense that you can kind of go through and pick and choose what elements you want to include and what elements you don't. And I'll get into the coding implementation later, but let's just map this out first. So for example, let's take example 1, where we have the input to be 1, 2, and 3. Now here, if we make our decision tree, so for example, at first, we're going to start off with an empty subset. Now here, and we have a pointer that points to the first element of the array. Now here, we have two options when creating our subsets, right? We can either include the element or we can not include it. So for example, like here, we can either not include one or we can include one. So if we don't include one, this is still going to remain an empty subset. Now if we do include one, one is going to be in our only subset. And now if we move the pointer to the second element, we can do the same thing at each node. So at each node we have two options, right? We can either include the element or we can't include the element. So here we can either not include 2 or we can include 2. And same thing on this side as well. So if we don't include 2, this is still going to remain an empty subset. If we do include 2, this is going to be 2. Now, if we don't include 2 here, this is still going to be 1. And if we do include 2, this is going to form a bigger subset, which is 1 and 2. Now, finally, we're at the last element because we moved the pointer over. It's the same thing. So basically, at each node, we can either choose to include it or we can choose not to include it. Now, so we can either choose not to include 3 or we can choose to include 3. So it's going to be the same thing. If we don't include 3, this is going to be an empty subset. If we do include 3, this is going to be just one element. And if we don't include 3, this is going to be 2. Sorry about that. And then if we include it, this is going to be 2, 3. And then if we don't include 3, this is going to remain 1. And if we do include 3, this is going to be 1, 3. And last but not least, for this last node, if we don't include 3, this is going to be 1, 2. If we include 3, this is going to be 1, 2, and 3. And just like that, we actually have our final result right here. And so basically the time and space complexity, so for the time complexity, essentially, so at every node, we have two branches, right? So we can either go left or right. So with that, it's going to be exponential. And so our base is going to be 2 because we have two different branches that we can go through. And we do this to the power of n, or at the power of the input array. And we evaluate this function n times, right? N times. So this is going to be the time complexity. And then our space complexity is simply just the height of the tree. So the height of the tree is, if you look at the levels, it's actually 3. So this is level 1, this is level 2, and then this is level 3. So because it's 3, it actually ends up working out to be the length of the nums, which is n. So that's why the space complexity of the recursive tree is n. And yeah, so let's get into the code now. Alright, so for this question, essentially first we want to initialize our global variables. So we have a global variable that is the result, and then also another one that is subset, which is going to be at each level. And then we'll define our backtracking algorithm. So here we'll make it a nested function, so then it can actually use all the other like variables such as like nums, res, and subset. And here we want to pass in a pointer I, which is simply just going to be the pointer at nums that I was showing in the drawing. So now here we want our base case. So our base case is essentially going to be when the pointer I reaches to the end of nums, and at that point we know that we need to return. So if our I is greater than or equal to the length of nums, and at that point we just want to append our subset to our result. So we want to append it like this, and we actually want to append a copy of it because we're going to use this subset and change the value of it in later recursive calls. So when we append the copy of it, we're just getting a snapshot of that subset at that specific point of time. So now we have our recursive case. And here essentially, yeah, so here we have to do the two decisions in the decision tree that we were doing, right? So first, we want to append the current nums of I to our subset. So essentially, this is the case where we are including the number. And then here we want to call backtracking on this on I plus 1 because we want to essentially, for example, we include this and then we want to call backtracking on the other ones so we can form the subset that includes that number. And then after that, with backtracking, we actually want to pop the current element that we just included, so we just want to undo what we just did and call backtracking on that. So that is not including the number. So here we can just pop the current number, and then we can use pop because append just appends that number at the end of the list, so pop just pops it from the end. And then we can do the same thing and call it on I plus 1. And I think that's it. I think that's it for our backtracking function. And then here we can just call backtracking of 0 because that's the pointer we're passing in. And then we just want to return the result. This one. Okay, we got it working. Essentially, what I missed was my return statement, and then I was doubting myself on this backtracking of I plus 1, but okay, it makes sense why you would need to include I plus 1. here, and then we submit it and it works. All 10 of the 10 test cases pass, and yeah. So hope you enjoyed this video. Please like and subscribe. It really helps support the channel. And yeah, see you next time.